The next topic we're going to look at is linear equations. So you'll notice to begin with, there's quite a few terms that you want to be familiar with. So the first one, what is an equation? So we say an equation is a math statement with two expressions that have the same value, and then the two expressions have to be separated by an equal sign. So you'll notice there's three examples already listed. Then we have a variable. So a variable, a lot of the time you want to think about that's going to be a letter, and that letter represents some unknown number. So for example, you could have the letter X, the letter Y, you could have an A, a B. Technically, you could pick any of the 26 alphabet letters available. In general, though, you tend to find a lot of questions will use X and Y, just sort of by default. Next term, you want to be familiar with what is a constant. So by definition, a constant is a number that does not change. But if we look at it, for example, I put -5, 3, 2.6, etc. The key thing is that a constant, you'll just be looking at a number. So there's not going to be any variable attached to it. Okay, so those are all constants. Coefficient is a number that multiplies the variable. So you'll notice I have 2x. Well, this would be the coefficient. So it's the number that's being multiplied by the variable x. Second example, this minus 15, that's considered the coefficient. It's being multiplied by the variable y to the power of 2. Okay, you'll notice I have an example to the side, so I'm going to point out. So in this expression, I have minus 3x plus 5. I'm going to point out. So the variable, that's your letter, right? So that's my variable. The constant, I always think about that's the value by itself, so not attached to a variable. So the constant is actually 5, and you want to take the sign in front. So if that was a negative, you would say it's -5. And then finally the coefficient, that's going to be a value that's attached to a variable. So the number I always say in front of the letter, so that would be the -3. Now, I did say that the new topic was titled linear equations, so it's probably good to have a general definition of what those are. So we're going to go with it's an equation whose graph would be a straight line. The focus in this unit, though, wasn't necessarily on graphing them, but it was working with the equations themselves. So what I've done, I've listed, there's 1, 2, 3, 4, 5 sort of different types. This one here, 2x equals 4. This one here, -3y equals 9. And this one here, those are considered one step because what happens, you have to do one step to solve it. And we're going to cover those type today. And then you have, for example, 2x plus 1 equals 5. That's considered a two-step. So it means there's going to be two operations you're going to have to do in order to solve for the value. And then this one here is going to involve distributive property. Okay, often people talk about using the opposite operation. So that's going to be a math operation that basically undoes another operation. So in class, I would often say, what's the opposite of adding? And you would tell me it's subtracting. What's the opposite of multiplication? And you would tell me it's division, and vice versa. It's also known as the inverse operation. So that's good to point out. And then I have written down there, so for example, addition and subtraction are opposites, so they will undo each other. And then multiplication, division are also opposites, so they will undo. So these undo, and these undo. Last good term to know, what is distributive property? So that's a rule that states that if you take A and you times it by B plus C, where the B plus C is in brackets, you will end up with A times B and A times C. Now that's super wordy. So here's what happens, right? If I have something being multiplied in front of the brackets, what distributive property tells me is that has to be multiplied throughout the brackets. So I have to multiply the A times the B, so that's how I get the AB, and then I have to go A times C. So that's how they're getting the A times C. So let's try an example with numbers. So if, for example, I had 3 times 2 plus 9, by distributive property, that's telling me I can go 3 times 2, and then I can add 3 times 9. So plus 3 times 9. When you clean this up, that's like saying you have 6 plus 27, and then you could even go one step further and say you would have 33. Okay, but the key part is the fact that when you apply distributive property, you would end up with 6 plus the 27. So 3 times the 2, and then plus 3 times the 9. Moving on to some examples. So we're going to look at solving what are called the one-step equations. So again, you're going to apply one operation in order to solve for that variable. Okay, keep in mind that variable, that's representing some unknown value. So for question A, we have 6 times x is equal to 12. What that's asking you is basically 6 times what number? Okay, so the x is representing that number that you're not quite sure what it is. So 6 times some number is supposed to give you 12. Well, one option is you could guess and check, and that's a valid strategy to use. The trouble with that, though, is as we continue on to grade 9, grade 10, 11, 12, it's going to get super difficult for you to just randomly guess values to get the correct answer. So instead of guessing, which is an option, let's actually use an algebraic strategy. All right, so I'm going to think about if I'm going to go 6 times x, this is being multiplied, right? So what happens, you apply the opposite operation. So maybe I'll add a little note here. What we want to do is we want to isolate the variable. That's a fancy way of saying get the variable by itself. So I want to get the letter by itself either on the left-hand side or the right-hand side. It doesn't matter. And to do that, we're going to apply the opposite operation. So for our first example, 6x is equal to 12, I need to undo the fact that it's being multiplied by 6. So I'm going to think, what's the opposite of multiplication? I need to know that's division, so they will undo each other. So I'm going to then divide this side by 6. Reason why I want to do that is I know that, well, think about it, 6 divided by 6, that's really equal to 1. So what happens is these are going to cancel out. Okay, now technically there's like a 1 here, but we don't need to write that. So I'm just going to write that they cancel out. Okay, the thing is though, when you have an equation, whatever you do to one side, you have to keep it balanced. So if I divide this side by 6, I have to divide this side by 6 as well. So then really I'm going to have x is equal to 12 divided by 6, I would get 2. Now, if you weren't sure, here's the good news. You can always check your solutions. So if I were to check it, sometimes called verifying, so I'll put check verify, I could think about, okay, so I have 6x is supposed to equal 12. Well, I just figured out that x was 2. So what I'm going to think about is, does this make sense? So if I sub back in the 2, so if I say x is 2, I'm going to check, does 6 times 2 give me 12? When you're doing a check or a verify, really important, make sure you want these sides to match. So I'm going to do one more step and go 12 is equal to 12. And then I know, yep, that is the correct answer. If for some reason I got like 13, right? If I had 13 was equal to 12, well, clearly something went wrong. So then I'd want to go back and double check my solution. Next question. So again, -5 is being multiplied by our variable b. So our letter b, b is representing some unknown value that we don't quite know yet. And we're saying it's supposed to equal -45. So the operation being applied is multiplication. We are going to undo that. So I'm going to divide this side by -5, include the sign. So that's negative, divide by negative. These two will cancel out. Whatever you do to one side, you have to balance out. So divide that side by -5. And we will get b is then going to equal -45 divided by -5. I should get b is equal to 9. And again, you could always check verify. You don't necessarily have to check or verify unless a question tells you to, but it is a good habit to get into if you have time to do it at the end. Question C. So this time n is being divided by 3 and it's supposed to equal 7. So some value of n, so some unknown quantity, when I take it and divide it by 3, I'm supposed to get an answer of 7. So this time the operation that's happening is division. So to undo that, we are going to multiply both sides. So if this is being divided by 3, I'm then going to multiply this side by 3. And you can think about this is like 3 over 1. You could clean it all up or realize that these will just cancel out. But whatever you do to one side, you have to balance on the other. So if I multiply this side by 3, I have to multiply this side by 3. And then I would get n is equal to 7 times 3, which will give you 21. Let's check or verify this one. So when I go to check verify it, this time I'm replacing this n with my answer, which is 21. So I'm just checking. If I take 21 and if I divide it by 3, will I get 7? Now again, in my head right now, I know these are going to equal out, but you need to show that the left-hand side equals the right-hand side perfectly. Okay, so you can't stop here and say you verified. You have to actually have this side matching this side perfect. And very last one, so we have W, it's being divided by -2, and we are saying it's supposed to give you an answer of 9. So this time I'm going to look. It's being divided by -2, so the opposite of that is multiplication. So if this is -2, I'm going to multiply both sides by -2. Those will cancel out, balance your equation, and I would say W is equal to -18. And again, you can check verify if you wanted to, if you had extra time. All right, now you get to practice some of your skills. So there's 2 sheets again. The first sheet, linear equations 1A. These would be questions similar to A and B. So where you're undoing the multiplication, so you'll be dividing to solve. So I'd suggest just focus on the evens for now. Again, if you want more practice, feel free to complete them all. And then the second page, linear equations 1B. This is similar to questions C and D. So where you are undoing the division, so you're going to have to multiply both sides to solve for your variable. All right, same deal. Practice the sheets. Check your answers as you go along. If you get stuck, please email me. I will help you. And then let me know. Would you say you are a happy face, you are the neutral face, or possibly the sad face? And then we will continue on with our next review lesson tomorrow. Have a great day.